Modulus functions. Modulus functions means the functions inside this two vertical lines. This is called the modulus. Whatever that you have inside it, the two vertical lines, this is called your modulus. And this modulus function, what it does is it will convert anything which is negative into positive, and if it is something that is positive, it will remain positive. So positive, it will remain positive, and a negative value after passing through the modulus function will become positive. For example, if you find the modulus, the absolute value function, the modulus function is also known as absolute value function. It will get you the absolute value. So absolute value of 4 will be equal to 4, and the absolute value of -4 will also be equal to 4. You have this function in your calculator. If you will see this over here, modulus is somewhere over here. The modulus and -4 is also 4, and +4 is also 4. So if you put in any negative, it will convert into positive. This will give you the absolute value. Absolute value is the distance from the 0. Okay, that's something later on, the basic or the more logical part, or if we go deeper, we'll go on deeper. So right now, the more relevant part is now you know that anything positive still remains positive after the modulus, and anything negative will become positive. So now if you have modulus equation, solve the following. For example, it is x minus 4 is equals to x, something like this, minus x. They are asking you to solve this. So how do you do this? Whenever you have, this is the modulus example of a modulus function. So when you open up, when you try to solve this, what do? You square on both sides. So when you square on both sides, you will get x minus 4 whole square is equals to minus x whole square. And if you open it up, x square minus 8x plus 16 is equals to x square. And the x square will cancel out. So you will have minus 8x plus 16 is equal to 0, and therefore your x value will come out as minus 16 upon minus 8 for 2. And if you input this complete thing again back into the function, into the question to check if you have got the right answer, you can confirm as well. I forgot about this example. The method is the same. I formed the question myself, so there are some issues over it. So, okay, let's suppose it is 3 minus x modulus is equals to 4. So how do you expand this? You will expand it the usual way. So whole square, squaring on both sides, is equals to 4 square. So you will, if after expansion, you will get 9 minus 6x plus x square is equals to 16. And when you move everything on one side, you will get x square minus 6x, and this would be minus 7, but this will be equal to 0. And then you can solve it quadratically, and you will get the answer 1 minus 6 minus 7. So your answer for x is minus 1 and 7, just like that. So you square on both sides and then simplify it, you will get the answer. And if you check this answer back into the question, if you put them back in the question, you will see that it is satisfying. Look, if I put in x as minus 1, so 3 minus 1 modulus, is it equals to 4? So yes, you can see 4 modulus will be equal to 4. So 4 is equals to 4. And if you have 3 minus 7 is equals to 4. So you will see minus 4 modulus is equals to 4, and minus 4 modulus is 4. So both are satisfied. They can confirm their answer like this as well. Whatever the solution that you get, you can put it back into the question and see if it is satisfying or not. For let's suppose this one, you have modulus 2x plus 1 is equals to modulus x plus 5. So what would you do? You would square on both sides. 2x plus 1 whole square and x plus 5 whole square. And then you expand it to 4x square plus 4x plus 1 x square plus 10x plus 25. Go everything on one side. So 3x square, and this would become minus 6x. This would become minus 24. Will be equal to 0. And again, use a calculator. Now, if you're in A2, then this would work. Okay, using your calculator to get the final answer, it is okay. You can do that. So you can see x is equals to minus 2 and x is equals to 4. So this is one of the ways of solving these modulus functions. Another way of solving these modulus functions is using sometimes by sketching as well. You should also learn how to sketch modulus functions. Sketching modulus function. Because this is also included in the syllabus. How do they work? How do they work? For example, you have y is equals to x. If it is only simple y is equals to x, what will be the graph? It would be a straight line passing through the origin, and this would be the line. Y is equals to x. But if I put in this equation modulus y is equals to modulus x, this is telling me that even if the value of x is negative, your value will y for y would always be positive, isn't it? Because of the modulus. So your values of x can be negative, positive, both. But after you input the values of x inside the modulus function, everything will come out as positive. So whatever the function for y is equals to x was, you reflect the part which is below, which is negative, in the opposite direction. So now this would be your graph for y is equals to modulus x. Because anything which is negative, it has reflected it in the x-axis. It is now in the positive y value, right? Because of the modulus. Y cannot be negative because of the modulus. Whatever the value of x is, y will never be positive. So if your x is positive, your y will remain positive. But if your x is negative, your y still remains positive because of the modulus. Because negative value modulus is still positive value. So everything reflected in x-axis. You can say like this. For example, you have y is equal to x minus x plus 2. So you will first of all forget about the modulus part. First, you sketch it the usual way. Find the x-intercept, find the y-intercept, just like the usual way. So y-intercept, forget about the modulus. Let's suppose it is minus x plus 2. So your y-intercept, easily you know it is the value of c, which is 2. So let's suppose this is your 2. Your graph is passing through this point. And then your x-intercept. Your x-intercept will be when your y is 0. 0 is equal to minus x plus 2. So x is equal to 2. X is equal to 2. So your line right now is passing like this. Right? Because you have the x-intercept, you have the y-intercept. And without the modulus, this will keep on going downward as well, in the negative y as well. But because now you have a modulus, this graph would be reflected. So this is the purple one is your modulus with modulus. Okay? Do you get it? The modulus will just reflect everything which is below the x-axis, which is negative, into the positive region. Same happens with quadratic graphs as well. For example, you have y is equals to x square minus 3. So if I sketch this thing directly without the modulus, this would be something like this. Without the modulus, the y-intercept is minus 3. Let's suppose this is minus 3. And the turning point is also minus 3. So your quadratic graph, the normal one would be like this. Easy. But now the problem is that the modulus part. So what will the modulus do? It will reflect everything that is below the quadratic. Below the x-axis. It will convert it into positive. Now it will pass through positive 3. The y-intercept, it was previously minus 3. But after the modulus, it got reflected. So now this is the final answer. Okay, so look at this. Reflected. That is below the x-axis has been reflected upwards. This is what the modulus. And now to solve these kinds of equations, modulus 3 minus x, modulus minus 4. There is another way, graphically as well. You can plot this part separately. Y is equals to modulus 3 minus x modulus, and you can graph this part separately. Y is equals to 4 on the same sketch. And the point of intersection would be your solution. Look, so modulus 3 minus x is this graph, and is equals to 4. Y is equals to 4. So look, it is intersecting at the points. The values of x are minus 1 and 4. The same two x values that we have found. Where x values, the points of intersection are minus 1 and 4. So this is another method, graphically solving equation. If you want to solve any of the equation over here, you can separate the graphs, you can separate the equation into two graphs and you plot them, and then the point of intersection will get you the solution. For example, let me do we solved over here, right? Where was it? Yes, this one. We will get the same answer using the graph as well, 2x plus 1. So this is your graph for this 2x plus 1, and then you have modulus x plus 5. So you can see they both are intersecting at x is 4 and x is minus 2. Yeah. Interesting. So you can solve them simultaneously like this as well. If you are confused, something, this is some just logical part of it. Otherwise, you can do it algebraically as well. Okay, now the problematic part is you know how to see this graph, you know how to solve simple modulus equations. But now you have modulus inequalities. The questions are, so these are the modulus inequalities. X plus 3 modulus less than x minus 4 modulus. So this is something that's different. So how do you solve this? It's very similar, but only one or two things are different. You will learn it. Okay. Now this is modulus inequality. So whatever the inequality is, I have brought in a modulus equation. Where is the inequality? X modulus less than 5 plus 2x. Solve or find the values of x. Set of values of x for which this is the question. So first of all, first step is forget about the inequality. Forget about inequality. So modulus x 5 plus 2x. Then solve it the usual way. X square is equals to 5 plus 2x whole square. X square is equals to 25 plus 20x plus 4x square. Move everything on one side. So 25 plus 20x, and then you will have plus 3x square. And then solve this simultaneously. 3, 20, 25. So your x is coming out as minus 5, and your other value of x is minus 5 upon 3. Now what do? You make a number line, a basic number line, and you draw these 2 points. So minus 5 is lesser, so minus 5 to the left side, and minus 5 upon 3. So, and now you make regions on your number line. So this is your region 1. The region to the left of -5, the region which is between these two roots, and the region which is to the right side of -5/3. Then what do? You take in any random value from the three regions. So for this one, you can take, let's suppose, -10. You can take -2. You can take 0 from here. And what do? You put these values. You take any random value from within the regions, and then you input these values in your question back. So if your x is, let's suppose, -10, so this becomes -10 modulus less than 5 plus 2, -10 modulus. And now simplify. -10 modulus would be 10, and 5 minus 20. So 10 less than -15. So 10 less than 15. So is 10 less than 15? Yes.
Yes.
This means that this part is, this region is part of the solution. This is satisfying the question. Then if your x is -2, so this would be -2 less than 5 plus 2 minus 2. So 2 is less than 5 minus 4 is 1. 1. So is 2 less than 1? No. So this part, this region is not part of the solution. And then if x is 0, so if x is 0, so 0 modulus is less than 5 minus 0 modulus. So 0 is less than 5. This means this is part of the solution. So as your final answer, you will say that your x should be less than -5 and your x should be more than -5/3. Okay, do you get it?
Yes, sir.
So you find the roots the usual way, squaring on both sides, finding the roots, and then plotting them on a number line, finding the different regions, then getting random values from the different regions, and then inputting back in the question. The parts which are satisfying your question are part of the solution. The others are not. This is your answer. Forget about inequality, squaring on both sides. So x squared plus 2x plus 1. X squared minus 8x plus 16. X square cancel out. So you will have 10x is equal to 15. X is coming out as 1.5. So only one root. So what would you do? 1.5. So any value which is above 1.5, any value which is below 1. Let's suppose below it is 0. You can check any one of the region. Don't need to check one of the both of them, because if you find one to be the solution, the other one won't be the answer. If you find the one which you are solving for as the wrong part, then the other part would be the solution. So if your x is 0, if your x is 0, this would become 0 plus 1 modulus greater than 0 minus 4 modulus. So 1 is greater than 4. No, so this part is not the part of solution. So this is the answer. So this means that x should be more than 1.5. Okay?
Yes.
Okay, let me do this one. So 3x minus 2 is greater than equal to x plus 4. Forget about inequality. Expand using the identity. So 9x squared minus 12x plus 4. x square plus 8x plus 16. Move everything on one side, so 8x square. This would become minus 20x. This would become minus 12. Minus 12, this is 0. Now solve it quadratically. 8 minus 20 minus 12. So x is coming out as negative 0.5 and x is coming out as 3. Now number 9, negative 0.5 over here, 3 over here. So the region value from between them, the easiest value that can help you to solve it is 0. Over here, it can be, let's suppose, 5. Over here, let's take it minus 1. So if x is equal to minus 1, 3 times minus 1 minus 2 greater than equal to minus 1 plus 4. So minus 3 minus 2 minus 5. Minus 5 modulus is 5. And 5 is greater than equal to 3. This is part of the solution. Then 0. If x is 0. If x is 0, 0 minus 2 modulus greater than equal to 0 plus 4. So 2 modulus is not equal to 4. No. This is not part of the solution. And then lastly, if x is 5. So 3 times 5 minus 2 greater than equal to 5. 5 plus 4 is 9, right? Yes. So 15 minus 2 is 13 is greater than equal to 9. Yes. This is part of the solution. So x should be less than equal to negative 0.5 and x should be greater than equal to 3. This is your answer. The 3 can now be multiplied inside the bracket as well. That is also one of the ways. Or you can keep it outside and square everything. That is also another way. But the method, everything is the same, still the same. So squaring on both sides, forget about the inequality, you will get 3, 2x plus 2x minus 1 square greater is equals to x plus 4. So this would be 9 and 4x square minus 4x plus 1 is equals to x square plus 8x plus 16. And then you can work it out completely. The rest of it is the same. Let's see something new that we can, everything is the same now. We'll complete this one, which I have given you right now, and then try these two as well in front of me. Complete the one which I have started, and then the next, these two. Okay. 36x
देखेंगे
square plus 36x plus 9. X square plus 8x plus 16.
सर एक्स स्क्वायर माइनस एक्स स्क्वायर है 35 एक्स स्क्वायर हो जाता है
X square minus 9. X square minus x square क्या है?
नहीं 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 नहीं, मेरी वर्किंग में मैं एक मिनट देखता हूँ मैं करता हूँ ऐसे फिर से ओपन फिर से करता हूँ नहीं
7/5 ही आ रहा है. I think the answer at the back is wrong. 36x square, 35x square हो जाएगा. So ये minus 44x and then okay. Whatever the solution that you have got, I think that is right. 7/5 and minus 1/7 and 7/5. And then what would you do? Complete it.
सर वो इसके बाद जो है बन जाएगा एक्स इज लेस देन -1/7 एंड ग्रेटर देन 7/5 तो जो है इनइक्वालिटी जो है वो 3 modulus 2x - 1 इज ग्रेटर देन modulus x + 4
and then make the regions from the using the number line.
हम्म
Then then
वो
put in
नंबर लाइन बना के तो वो बन जाएगा x से जो है लेस देन होगा -1/7 और ग्रेटर देन होगा 7/5। वो यूज
no
हो।
sir you don't. अच्छा ये पूरा करके बता रहे हो?
हम्म
You're giving me the final answer after putting everything the values from the number line everything.
नहीं, वो तो ऊपर रूट्स जो है वो वही आएंगे ना, -1/7, 7/5।
What is the next step then?
इसके बाद जो है
Now
वो
you
नहीं बनाएंगे हम
number line
कर्व। हाँ नहीं, ठीक है। नंबर लाइन एंड नंबर
is not
लाइन के।
is not quadratic. This is something else. वो वाला याद नहीं है वो तो थोड़ा भूल जाओ. That is AS. It's A2. And now you have three regions. Region 1, 2, and 3. And then you will put in
हम्म
values from this region. Let's suppose this is -1. You can take -1 from here. From here you can take 0. From here you can take 2. And then you will
हम्म
input -1, 0, and 2 in the question there. And set it and find if which one satisfies.
ओके ओके।
Three
ये
times
एक्स की वैल्यूज जो हैं ये हमने ठीक है।
you will get 9 is greater than 3. Yes, 9 is
हम्म
greater than 3. So this is part of the solution.
हम्म
And then put in 0, put in 2.
ओके ओके ओके।
3, 0 minus 1,
हम्म
0 plus 4. So 3 is greater than 4. No, this is not part of the solution.
ये नहीं है, और अगला जो है वो 3 है, दैट मीन्स के
3, 4 minus 1.
1 3 9
3 plus
9 इज ग्रेटर देन 7। ये भी सही है।
yes. So your x is greater than 7 upon 5 and x
हम्म
is less than negative 1 upon 7.
हम्म लेस देन -1।
Okay.
ठीक हो गया।
So the next one is I'm stopping the recording.